Hello everyone, welcome to Robotics course, and this is the unit 1 wherein we'll be discussing robotics basics and classification. So here I have listed the certain topics that we will discuss in this particular unit. There are about 5 to 6 units that we'll cover in this course. So this unit particularly comprises of these 6 uh, topics, wherein first we will be discussing basic definition of robotics given by Robotics Institution of America, then certain introduction on robotics, followed by we'll be discussing components of a robot, then degrees of freedom and six degree of freedom of a robot. Then we'll discuss the classification of robot into multiple categories. The main is the classification based on the configuration. We'll come into that when we'll be discussing that particular topic. And the last topic for this particular unit will be end effector as a tool and as a gripper. Now, what is end effector? It is one of the most important components of a robot. So, when we will discuss the components of a robot part, then I'll give you a brief about end effector and we'll explore it up to a good extent when we'll be discussing the last topic of this particular unit. I'm telling you again, there are about 5 to 6 units in this robotics course, and we'll be, learning and trying to understand the different concepts carefully one by one in detailed lectures. So, thank you first of all for clicking on this particular video, and I'm pretty much sure you'll learn something from these video lectures. So, without wasting any time, let us start with the first topic. But again, without a brief introduction my, of myself, it will be inappropriate on my side to start. So my name is Krishang. Who am I? My name is Krishang. I am currently in fourth year at Delhi Technological University, and I'm doing my undergraduation in mechanical engineering only. I do not like to brag about myself, but certain things I am very proud of. Like I was the class topper in my first year, and DTU awarded me a sum of 10,000 for my academic achievement. It's not a good amount. In fact, it is a good amount for a student of first year, and it was really very motivating for me. And you know, since my first year, I've tried to be good at whatever I do, be it academics or be it extracurricular. So, yeah, that is about me. So now we are good to go with the introduction and definition of Robotics Institution of America. Okay, so let us start with the first topic, which is introduction and definition of a robot. Now, if I talk in a layman's language, why would I need a robot? Why would I need a robot? It could be to automate something, right? Or it could be to, like you have ML models right now that are used for predicting. So it could be predicting something. And why am I saying this? Because like you have certain different integrated concepts that you put in a machine that gives you some result based upon this model, and it is doing this on its own. Like for example, you have certain recommendation systems in your Netflix or maybe Amazon Prime that give you an output based upon your search history and all of that. So that is also part of a robot. There are certain intelligence that is involved behind all these systems. So you can use a robot for multi purposes. Now, what else? It could be to it could be to replicate, what happens in the industry. So industrial purposes, like for example, if let's say you are in in a manufacturing industry, right, wherein you need to, let's say you have this object, you need to pick it using using certain component, and then you need to place it in a certain, you can say, under a certain apparatus that in turn performs a part. So it could be used for pick and place, not just automated. It could be used for pick and place. It could be used for pick and place, right? And then you also have certain different applications of robot. It could be, it could be, it could be used in welding, right? For, automatically welding. So basically, the core is automate. The core is automate, and all of these are its extensions only, right? And in welding, you could do continuous arc welding. You could do it like this also. Like you'll be what you'll do. You'll put your you'll put your torch over here, and it will continuously keep on welding till this point, and you can feed these two coordinates inside your robot's processor, right? Basically, you ask your robot to, learn what these coordinates are, and you'll give certain intermediate coordinates that the robot can follow. So on the core and the main function of a robot, we can uh, zero down up to this particular first point, which is automate. Now, various definitions of a robot are followed. When we are documenting things, and various definitions of a robot, like of what is a robot. So a robot's definitions are, they could be, then they're numerous. But to accept a standard, we we follow the definition that is given by RIA. And what is RIA? RIA stands for Robot Institution of America. So, uh, wait just a second. Yep. So, Robot Institution of America. So, not just writing, I'll also help you learn what all I teach you, right? So, if I convert the definition into pointers, so basically it describes a robot into broadly these categories. It calls a robot reprogrammable. It is something with programming. Then it also calls it to be multifunctional. It could be used to perform various tasks. Then third, it could be known as a manipulator. We'll come into that. It is basically a component of a robot only, but if we need to learn this, then we can zero down the definition into these three small subpoints, which is a robot is something that is reprogrammable, it is multifunctional, and it is a manipulator. Or you can further go down and you can call it to move specific tools. Right. So the Robot Institution of America, it it says that a robot is something which is reprogrammable, it is multifunctional, and it is a manipulator. Basically, it is used to move specific tools. Now, what exactly is the definition that is given by Robot Institution of America? So it says that a robot is a reprogrammable, multifunctional manipulator that is designed to this part. Why? To move specific tools, parts, materials, and specialized devices through, now this is an important part, through variable programmed motions to perform different tasks. My bad. Right. So a robot is a reprogrammable, multifunctional manipulator. We can, change the instructions that we give to a robot, so it is a reprogrammable. Then we can perform different tasks using a robot. Broadly it is automation, but we could also, let me write down here only, but uh, we could also use it as a tool, for example welding, or as a link, or as a special device to perform certain tasks, right? And this could be to, not in tool I'm also covering welding, then I'm covering uh, 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 let's say, but different other parts. It could be used in machining, right? It could be used in machining, like for example it could be used for drilling and all of that. So these are, you are basically automating all these processes. So the particular term tool and the other part we will discuss that in when we'll be discussing the end effector part. But you can, for currently you can, understand that the tool here means welding, machining, drilling, and all the other equipment that is used in these processes. So you use robot for all these processes. You can use robot for all these processes. And why are we doing so? To first automate, and then second, to to, it could be to cut down on workforce. It could be cut down on workforce. Next, certain different processes might be risky for for humans, and they might have potential hazards. Like it could be, in locations and in processes that require us to stay in high pressure and high temperature chambers, or wherein there is a high amount of leakage of gases. There is a risk of high amount of there is a high risk of gas leakage, and different, all such harsh conditions for humans. In these conditions we might use a robot that can perform, if not better, but at the same level uh, of a human's performance, to carry out the same task. And it also helps us, to automate the repetitive tasks and increase the efficiency by reducing the time it takes to do the whole process. So I would need a robot not just to automate, but to perform multi functions. What functions could be? Functions could be multifunctions. Okay, let me do it here. Multifunctions could be, first is automating, right? Automating. Second is uh, reducing human effort which basically any machine does, but still reducing human effort. Human intervenes in harsh conditions and carrying out repetitive tasks, right? So these are mainly some functions that a robot is capable of doing, and all the other functions would fall under one of these categories, right? So a robot is a reprogrammable. We can change how a robot is programmed to do under certain conditions. It is multifunctional, something multifunctional. That means it can perform different tasks broadly in these three categories: automating, reducing human intervention, and carrying out repetitive tasks. And is a manipulator. Basically, manipulator means it is something related to moving specific stuff. So, moving specific tools, parts, materials, and specialized devices, right? So, it is moving certain different components of another robot, maybe, or any machine, or any industrial component, or any of that sort, through variable programmed motions. So, not just the functioning of a robot, I can also reprogram the way a robot is moving for transferring goods. So reprogrammable is related to the motion of a robot as well as the function. So we can change these two based upon the task that we want our robot to do. Hence, we are calling it reprogrammable. We are calling it multifunctional because we want it to perform these specific functions, or any of the other functions that might fall into these categories. And third is basically to behave as a manipulator that is designed to move these tools under variable programmed motions to perform different tasks, right? So what is a robot? A robot is a reprogrammable, first, second multifunctional, third manipulator, designed to move specific tools, parts, and materials and specialized devices through variable programmed motions to perform different tasks, right? If you just remember these three terms, reprogrammable, multifunctional, and manipulator, then you can recall the other part of the definition. So reprogrammable, something related to motion and function, right? So motion, variable program, motion. Multifunctional, something related to performing automation and reducing human effort, carrying out repetitiveness. Okay. Manipulator means something related to joints, links, moving, and all of that stuff. So designed to move specific tools, parts, materials, and specialized devices through variable program motions, right? So this was about a brief about robots definition that is laid by Robot Institution of America. Why do we need a robot? What all categories can we divide a robot into? And uh, yeah, so this was all about for this particular topic in this unit. Next, we will be discussing components of a robot. Components of a robot, right? So, I hope you now remember the definition as well of a robot. So, a robot can broadly be divided into these components. First is the end effector. You can change the order in which we'll be, discussing, and if consider it as the hand of a robot, right? Next, you have sensors attached to it. Consider it like consider it analogous to, not analogous, analogous to the eye of a human, the nose, skin, basically all sensory organs of a human. Next, Next, you have a control unit that basically, controls or programs how uh, a robot will function, and it interacts with the sensors to basically change the functioning of a robot in case it, goes out of the track. Next is the drive unit. So drive unit basically uh, comprises of, it could be pneumatic, it could be hydraulic, or okay, one second, it could be mechanical. Hydraulic is something related to water. Hydro. Pneumatic is something related to air, and mechanical is something related to joints and links. And the most important component is the manipulator. We discussed this in the definition as well. Here. Oh, here. Right. It comprises of joints and links. Right. And these are the main components of a robot. You might end up, finding certain different smaller components of a robot, but broadly, the main components of a robot comprise of manipulator, which again contains joints and links, then the end effector, which is the hand of a robot, then sensory organ, or you can say the sensors of a robot, followed by control units and a drive unit or driving unit, right? So we discussed the components, or we just listed down the components of a robot, but how would a robot look like? And can I draw a diagram which has all of them? Well, definitely I can. We'll be discussing broadly about uh, the different categories and types of robot once we come under the configuration of robots. But just to give you a feeling of how a robot would look like, we'll be uh, drawing something which is known as a jointed arm robot, or it is also known as basically it is known as articulated jointed arm robot. Right. So, how will it look like? It should have a sensor. Broadly, it should at least have a manipulator, and it should at least have an end effector. If let's say I cannot show the sensors, control unit, and driving unit, so the diagram should have a manipulator, or basically a body. Consider it as the body and the hand, right? So a basic, I know when I say the word robot, there is a basic figure that gets developed in our mind that would look something like this. Okay, this is a this is a robot and it has a hand, right? And it does something. You might have seen certain machines that they have a basically a banner or something attached with their hand, and then they just wave it up and down for promotion purposes. So this is this is also a robot. This is a basic diagram of a robot, but it is not looking that good. So we'll draw a better diagram of articulated jointed arm robot, or simply jointed arm robot, that looks something like this. So it has a base. It has a base. Okay, one second. Let's draw it neatly. It has a base. You can draw alongside, and it is a simple diagram, and it is a very important diagram. Then, okay, what is this? It is the base, and you need to have certain support on which the body of the robot would rest, right? So it is the base in this case. Next, on this base, you have the body of a robot. I can remove this part, and right. And on this, you have some arm kind of thing that looks like this. Right. And you have a tool that will, like for example, this can be, you can assume that this particular section will look like this, and it will hold this particular banner. This is banner, this is movement. I'm telling it, I'm calling it movement, right? And these are what I'm calling as links, or you can call it arm over here. This particular thing is the joint, and joints and links are attached to each other, and we'll come into that. This is also a joint. This, you can call it, basically the whole part is a body only, but you can call it body. And this particular type of robot, the articulated jointed arm robot, resembles like the human arm, right? It is looking like this particular part, this whole part, it is looking like this. And the movement of this whole part is similar to the movement of a human arm. This particular part, you can, you can stretch your hand, and you can try moving your hand in different possible ways. The same movement can be achieved by this particular robot, which is the articulated jointed arm robot. And this particular robot can move in this direction. Basically, this particular arm can move in this direction, rotate in this direction. Then you can also rotate this, the lower arm, the upper arm. You can rotate both these arms, and you can also rotate the body of the robot about the base. So you'll have a theta one, you'll oh oops, you'll have a theta two, and you'll have a theta three. So this particular articulated jointed arm robot has basically an upper arm and a lower arm. Both can rotate by different angles, theta 2 and theta 3. And the third rotation can be achieved by rotating the whole body. Right. So the main idea behind this particular concept is, I have a robot that is placed over here. Okay, let us call this particular robot, this particular stuff as a robot. This was this yeah, this is a robot. Let's call it a robot, and it has an arm. It has an arm, right? Our main task is, currently I'm assuming that our robot is fixed at a particular position, and I'll go back to my definition. Oops. I'll go back to my definition. It is a manipulator, right? It is a manipulator. It has joints, it has links. Now let's say I want to use it for industrial purpose. Why? For, let's say, picking up a component and placing it in the drilling machine, under the drilling machine. So I assume that my component is kept on this particular table, right? I have my component and on this particular table, and this arm. Okay, let me add this functionality with the arm. The arm can reach this particular uh, object, and it needs to place it on, let's say, this table, wherein I have I have a drill bit, wherein I have a drilling machine attached, right? So my main aim is to pick this particular object and place it over here so that I can drill it. And my object and my robot is fixed. So what I'll do certain movements with my arm to get over here. Let's say initially my arm of the robot was over here like this, right? So to get from this particular position to this and then to this, so we have three positions, A, B and C. To go from A to B, I'll have to move this by some theta, right? Let's call it theta 3 only. So now let's say I get this angle now. Let's say after this theta 3 rotation, I get this, right? And to get to B, I also need to move this particular arm by theta 2. So let's now move it by theta 2. By doing so, we'll reach this particular configuration, right? So I have used theta 3 and I have used theta 2 to basically hold my object. And I'm assuming that I'm able to hold my object. Now, to move it from this to this, I am assuming that this is placed in a circle, right? I'm assuming this is placed in a circle. To move my whole object from this particular position to this particular position, I need not change the angle. I'm assuming that this height and this height is also same. I need not move my arm. I need to just rotate. So I'll rotate by theta 1 and my arm will hence be over here. So I moved my object from A to B using theta 3 and theta 2 and from B to C using theta 1. For, let's say my aim was to create a robot that can, replace my workforce that is just being employed to move the parts. So I can just, place a robot over there, give it some commands, and I'll program it to just move components from A to B to C. So this was just one function, but it seems logical. Like, okay, it is not a need that I'm creating on my own. It is definitely a need, and to fulfill that need, only we are investing in these types of robots, and these robots are basically based on this particular framework of an articulated jointed arm robot. So this particular robot might have some sensor attached to over here that can, tell that whether this object uh, is the one that I selected to drill, right? So this particular area can also have a sensor attached to it, and to move this arm based upon the function that is moving from A to B to C, I might have a driving unit and a controlling unit that can, the controlling unit will send some commands to the driving unit, which in turn will move the arm for this particular process. So if I draw, okay, let me go up. If I draw the way we'll be using these components, so first or second, you can consider both of them to be together. First will be these two. So these two will control how the movement will take place. The movement could be of the end effector, which is the hand of the robot. This particular part can be labeled as the end effector of the robot, right? End effector. This is the end effector of the robot. So these two will control how the end effector and the manipulator function. Manipulator contain joints and links, right? This is joints and links, and end effector, this part. So basically, I'll have some controlling unit and driving unit. The controlling unit, it could be a PC, right? It could be supercomputers, it could be anything. It could be a mobile phone also. it will control this alongside the driving unit will control how this particular system works. So this was a brief about the different components of a robot. You might, as I said before, you might have other components as well, but broadly, the main components that are important to learn and to understand are these five components: manipulator, end effector, sensor, control units, and driving units. We'll discuss it a bit more in the next lecture, just to write it down quickly and to memorize. Okay, this is this, this is this, this is this, and this is this. Great. So we have completed these two topics in this particular video, and in the next topic we'll be discussing about the degree of freedom and the sixth degree of freedom of a robot. So you might have different uh, configurations of a robot. In industrial robots mainly have six degrees of freedom. Degree of freedom is basically the different directions in which my robot can move. So X, Y, Z. If let's say my robot can only move linearly in X, Y, Z, then it is said to have 3 degrees of freedom, right? If it can rotate also, so then it is four, and so on. So basically, we have 6 degrees of freedom in an industrial robot. It could be more, it could be less, but generally it is six, which is accepted. Next, we'll learn classification and end effector. So this will we'll cover in one video, and these two might take two, and this will take one. So in total, this took one, right? So in this unit, we'll have about one, two, four, five videos for this unit, and I'll ensure that I'll be as clear as possible. So I hope you enjoyed this particular lecture. If you did, then please subscribe to the channel. And I also post videos about coding and Python and all of that stuff. So make sure you watch them too. So thank you for watching this. Please like also and comment down whatever you want to comment. Great. Thanks for watching.